All right. Hey, good morning. It's Mr. Murray coming to you with a video recap of what we're going to be doing today. Unfortunately, I'm out, so I'm not going to get to give you the full rundown as I would do in person, but I am going to give you a breakdown of what you need to know for today. So you are going to be doing a lesson deliverable that will be posted on the Google Classroom. I will provide you with some important information you need to know about that. Please do keep in mind that today is the last day of the term. That is not changing. I will have office hours immediately after this period, beginning at 11 a.m. Please follow the Google link, the Google Meet link in the classroom, and you can get access to those office hours in the event you need to ask me any questions or check in concerning anything. So again, you should receive handout 1-7. It is located in the front of the room. I've asked that to be given out to you. And hopefully that was able to be given to you. Another copy is also available on the binder checklist that you can find on the Google Classroom. The objective for today is that we are going to define a function in terms of its inputs and outputs. What is a function? We'll talk about it in terms of algebra, geometry, table, and context, also known as the AGTC representations. All right, so we'll do our do now. We'll have a recap of slope-intercept form. This will be in preparation for a new MyHRW assignment that has been posted, reviewing slope-intercept, and then we'll talk about what a function is. All right, so folks, let's go ahead and get started. What we're gonna do is use the slope formula to find the slope between the points 2, 5, and 4, 11. You may wanna use the 11, 4 lesson deliverable to help you. So if you wanna go back and look at what you submitted to the Google Classroom, that might be a good suggestion for you to pursue. So folks, please take a moment, pause the video, try to find the slope between these 2 points. Okay, then when you're ready, unpause and you can see what I got. All right, so I would suggest if you have not done this that you consider first, what is the slope formula? So that's really important. Now, if you don't know the formula for the slope of 2 points, here it is. So remember that slope in general is the rise over the run. Formulaically, y2 minus y1 over x2 minus x1. Okay, that is the slope formula. If you have 2 points, x1, y1, and x2, y2, it does not matter which one you label as which. I will label this as x1, this is y1, this is x2, and this is y2. And I'm going to show you the 2 important things. Now, if you did not know that, I still encourage you to pause the video because this is going to be the first thing that's going to go down in your lesson deliverable, and actually take a genuine attempt at it, because we don't want to just turn it in for the sake of turning it in. There is actually value in trying to do these out. All right, so I'm going to set up my slope. Y2 is 11, y1 is 5, x2 is 4, x1 is 2. Now, remember a couple things you're going to know you got it right. Remember our 2 things we said. The y's are the rise. That's one thing we know. The other thing we know is that if you box the points that are together, the x and the y are always on top of each other. Let's take a look. So if you take a look, 11 and 4, they're together in the point. 5 and 2, they're together in the point. Notice so that's check 1, and the y coordinates are up top. Check 2. If you can do that, there's a very, very strong chance that you are going to have the correct answer. 11 minus 5 gives us 6. 4 minus 2 gives us 2. One thing I still have not seen, and this goes all the way up to honors and even college, believe it or not. Even college kids struggle with this. Please don't forget to simplify your fraction. So in this case, 6 over 2 is 3. I would expect you for sure to simplify fractions. And if that's something you're struggling with, that's okay. but we do want to talk about that. Okay, so in this case, your slope should be 6 over 2 or 3. Okay, and so this is going to be the first thing that goes in your lesson deliverable. Remember, you want your name, you want the date, and you want this problem to start. So please take a moment if needed and make sure you have that all on there. And then we will move on to talking about a little bit more about slope-intercept form. All right, so as we learned, and as you may know from previous years, slope-intercept form is y is equal to mx plus b. Why we use m, again, is not necessarily known. Other countries, I believe even European countries in Europe, they use a instead of m. You'll see actually if we ever have a chance to look at the TI calculator, that the TI calculator also prefers to use a. Doesn't really matter. I don't really know that it's known why we call it m. The letter choice doesn't really matter. So we just choose m. M represents the slope. Remember, that is the rise over the run. And 0 comma b represents the y-intercept. Remember that if there's a negative sign there, the negative, like the minus, goes with the b. So you got to just be aware of that. Be aware. So I am going to discuss two different types of problems that you'll see come up. And this is called write the equation of the line. So this is another thing that we are going to need to add to the lesson deliverable. You don't need to have the information from that previous page, but this does need to be added to your lesson deliverable for today. Okay? So that being said, there are actually three different types of situations you're going to actually run into with respect to slope-intercept form and writing the equation. We're going to talk about two today. And then when we come back on the next day 2, which I believe is later this week, I'll show you the third type where we have to find the slope as well, because we have 2 points. Now, here what we have is I'm telling you the slope and I'm telling you the intercept. So remember, for any equation, you know that m is the slope, and we know that 0 comma b is the intercept, okay? So in this case, there's basically 3 scenarios. One where you have the slope and the intercept, one where you only have the slope and you need to find the intercept, and a third where you need to actually find both the slope and the intercept. So in this case, we actually have both of those. So I'm going to take the 3, and again, make sure this goes in your lesson deliverable. Plug that in. 0, 10 means that this needs to be a 10. Okay? All I'm doing is I'm taking the slope, the number, and the intercept, and plugging them right in. Now these ones, it's kind of like all the information is right there. Not very common to come up, but you know, it is a possibility of a kind of problem you can get. So please make sure you understand how I did that, and then I'll go ahead and move on to the next one. All right, now this one's a little bit more tricky. So I tell you the slope, but I don't tell you the intercept. Here's what we know so far. We know that y is equal to 2x plus b, right? We know the slope is 2. We were actually told that. We don't know what b is, but here's what we do, right? So we know that it passes through this point 3 comma 10, right? Where 3 is the x and 10 is the y. So think about it. What information are we given here? Well, we do know this. First of all, y is equal to 10. We know that because if it passes through the point, what we know is that if y were to be equal to 10 and 2 were to be equal to 3, then both sides of the equation would have to be true. And we had such an amazing conversation about this yesterday with cohort 1. I'm bummed we can't have the same conversation today with cohort 2. All right, but that's okay. So what you're going to do is you see here, you take the point you're given, in this case 310, you plug the x in for the equation where you see x, the y in where you see y, right? Because every equation needs an x and a y. See how I left that in there? Now what we don't know is b. But if we have figured out every number other than b, then we can just solve for it. Here's how we do it. Right? We got 10. Now what's 2 times 3? That's 6. Could say 10 equals 6 plus b. How do we figure out what b is? Well, what we do, we subtract on both sides, and we get 10 minus 6. is 4. 4 is equal to b. And now we come over. We have y equals 2x plus 4, right? You're done when you figured out all of the possible values. Okay, so please make sure that you do have these both fully done out on your lesson deliverable. And if you need more time, again, feel free to rewind, pause, whatever you need to do. And we will be moving on to the meat of the lesson in just a couple minutes. Alrighty, so this is actually going to be the 1-7 sheet, and we are going to be spending the remainder of the video focusing on this 1-7 sheet. This 1-7 gets us introduced to the idea of a function through this example of the cola machine. So this comes back to the day when there actually used to be soda machines in school. And I always talk about, I used to have like ice cream vending machines. It was hilarious, right outside the gym, right? You think everyone would be working out, everyone would be thinking about health, right? Like literally right outside the workout room, you'd have soda, candy, ice cream, any kind of junk food you get. Now, nowadays, they don't really have that as much, right? It's more focused on healthy food, and that's probably for the better. Having the water, the soda. I know it might not seem that way, but I kind of wish that I had that instead. Believe it or not. I know it sounds weird. I mean, when I was 16, right, I was like, yes, right? But now it would have been nicer if we had some healthier food. All right, and even some water, some seltzer there. All right, so you have to bear with me. This is not super relevant, but in any case, here we go. So the soda machine at your school, it offers several types of soda. All right, now there's 2 buttons for your favorite drink, Blast. While the other drinks, Slurp, Lemon Twister, and Diet Sharp, each have 1 button. By the way, I did take this activity from the College Preparatory Mathematics book, so I do want to give credit to them. Thank you very much for helping me with this activity. It is adapted from them. All right. What I want us to start by doing is describing the inputs and the outputs of the soda machine. What are they? Well, let's think about it. What do we put into the soda machine? Well, we put money into the soda machine, so let's make sure we write that. And let's talk about the buttons. What buttons could we press? So I'm gonna write this little squiggly bracket, little S, backwards S, and I'm gonna write the different buttons. Blast, I was gonna write each one. Now, I only write blast once. There's 2 of them, but once I already know blast is coming out, right, you don't write it again. And we might remember seeing these sets from when we talked about probability in our last unit. Okay, so blast, slurp, lemon twister, diet sharp. Now it does say diet slurp on the machine. It should say diet sharp. Okay, no big deal, but we will go with the ones in the problem. All right, so think about a vending machine in your real life, right? So in order to get something out of a vending machine, right, first you have to put the money in. Hopefully you've all used some kind of vending machine before. And then you got to press a button to tell me, what do you want? What's going to come out? It's going to be a soda. Okay, and how do you know this? Hopefully because you've used a vending machine before. All right. Hopefully this makes sense. Okay, so this is part A, right? Getting a feeling of what do we expect the inputs to be? What do we expect the outputs to be, right? Eventually we're going to transition into numbers, but let's start with like a scenario that's maybe more familiar to us. All right, so please make sure you have this. As we go forward, I'm going to put a little bit more and more on you, okay? All right, so here's the one scenario. So I'm buying a soda. I'm going to push a button for lemon twister, and out is going to come lemon twister. Now, later in the day, my best friend in the whole wide world, BFF, big time, miswritten, went to the same machine. She's going to push the lemon twister button, and she's going to get a can of the orange blast. Okay? She's a little bit upset by that, though, right? Is the machine functioning consistently? Think about what it means to function consistently. Is the machine functioning consistently? Why or why not? Please take a minute to pause the video. See if you can answer the question. Is that machine functioning consistently? And then when you're ready, unpause, and I'll show you what I got. All right. So what we know is the machine is not functioning consistently. It is not functioning consistently. Now you might have a verbal definite, like a verbal explanation. I'm going to suggest that you leave it if you have it, but see if you can add this picture as well. Let's think about what we got here. So this is a picture of, here's the button, right? That lemon twister. Now, when Mr. Moray pressed it, I guess when I press it, right? Moray, what we get is a can, and you don't have to draw the can. You can if you want, but let's make sure we have the words, right? I get the lemon twister. But later in the day, right, we get a different scenario. Here, Miss Ritten comes by. She presses the same button, but she gets orange blast. So what we have is a scenario here where one input has two different outputs. Okay, that's not functioning consistently. If the machine was functioning consistently, whenever we press that lemon twister, we want to get one different type of soda. So you might say this machine is malfunctioning. Mal is right, bad, functioning badly, right? And this idea of function and functioning, right, is going to be kind of like a theme that's going to continue to show up now and probably throughout high school, maybe even beyond. All right, so please make sure you have this written down in B. Take a few seconds to finish writing it down if you need to. Again, this will be checked as part of the deliverable. It should be on a note sheet that you've received. I would like you to try to draw the diagram. You don't have to draw the button and the sodas. If you want to, you can. At least can you put the words in there and show me the arrows? All right, and then we will move on in just a few seconds. Okay, so that's the first scenario. So here's another scenario. All right, Brandy. Now Brandy pushed the can of top button to blast. So here's the one trick. We got to just go back to the machine. Remember how there's two buttons for blast. Now this goes back to a time in which back in the day, right? Pepsi machines, Coke machines, they used to have a couple buttons for their signature products. So like Coke, you might know, has multiple different types of sodas, right? It's not just Coca-Cola. They might have like, I don't know, I think they might have like a root beer. They might have like an orange soda or something, right? They got a bunch of different types of sodas, flavors. But usually what they would do is their signature brand for Coca-Cola is Coke, and for PepsiCo is Pepsi, right? So Pepsi has like Mountain Dew, I think maybe Fanta. I don't know the brands. I'm not a master of this stuff. But they would have two buttons for Pepsi because like that was the big product, Pepsi. So similarly, right, you can see Blast. This is a Blast machine. Blast is that signature product. So there's actually two different buttons for Blast. That's important to note. So Brandy pushes the top button for Blast. She gets a Blast. Miguel decides to be different. He's going to push the bottom, the second button for Blast, and he's also going to receive a can of Blast. Is the machine functioning consistently? Why or why not? Please take a moment to try to figure this out. See what you think. Again, please leave some space for a potential diagram, and then we'll come back in a moment and see what you got. All right, so here's the scenario. The answer is yes, the machine is functioning consistently, right? And that's because each button leads to only one type of soda coming out, right? Obviously, for full credit, I'm expecting you to do this in your own words. All right, here's what it looks like. This is the top button for Blast. This is the next button for Blast, right? There's two different buttons. This is the one that Brandy presses. This is the one that Miguel presses. In either case, What comes out is blast. So even though you have these two different inputs, each input has the same output. This is a common misconception that people have with functions. They say, oh, two inputs have the same output, that must be bad. That's actually not true. And here's an example. Think about what happens when you square 2. Think about what happens when you square -2. Well, to square something means to multiply it by itself. So if I square 2, that's 2 times 2, which is 4. If I square -2, that's -2 times -2, also +4. So if we think about a kind of rule where it says take the number and multiply it by itself, here's a scenario where two different inputs have the same output, and that's okay. So that, again, is a big misconception. It's okay. A lot of people struggle with that. But again, the big thing we need to think about is that every time I press a button, I only get one type of soda coming out. And even though two different buttons could lead to the same type of soda, individually, each button only is ever going to have one type of soda coming out. And that is what makes it, yes, functioning consistently. All right, so again, please take a moment. Again, please try to have the diagram down there. This should be getting added to your 1-7 sheet. And then when you're ready, go ahead and please move on to the next part. All right, so this is scenario 3. The next day, Miss Michaels went to the machine and pressed the button for Diet Sharp. She's more of a soda fan. Much to her pleasant surprise, she gets a can of Diet Sharp and a can of Blast. Now, she is happy to get 2 sodas for the price of 1, but should she be concerned about whether the machine is functioning consistently or not? So please take a minute. Try to figure out, should she be concerned? Is it functioning consistently? Why or why not? And then when you're ready, unpause, and you'll see what I got. All right, here we go. So she's pressing, so she should be concerned. Yes, she should be concerned because one button or input has 2 different outputs. Okay, here's what it looks like. So she presses the button for Diet Sharp. What comes out is 2 different things. At the same time, she gets the can she wants, which is good. But then she also gets another can of Blast. Okay, that is not good. This is not functioning consistently because the problem is you're pressing a button and you're having 2 different types of sodas coming out. That's not consistent with what we'd expect, right? The expectation is we press Diet Sharp, only one type of soda comes out. So this is important, right? The expectation, we press a button, we're only supposed to be getting one type of input coming out. All right. Okay, so again, please make sure you got this down on your 1-7. We're not actually, believe it or not, on the back side of it. So if you haven't found that, please do so. And then in a moment, we will move on to the final scenario, and then we'll begin to formalize some of this language about what functions are. All right, last scenario, we have Lutfi and Taisha. So when Lutfi pressed the button for Slurp, he received a can of Twister. Okay. Now Taisha presses the button for Slurp. She gets a can of lemon Twister, and she notices that everyone who pushed the Slurp always receives that can of lemon Twister. Here's the question. Is the machine functioning consistently? Why or why not? So again, please take a moment, try to answer this in your own words. Again, please leave room for a picture. You're welcome to draw the picture if you'd like on your own. And then in a moment, we will come back and see what you got. All right. So what we're looking at is a scenario here. We have this machine actually, yes, is functioning consistently. Okay. Even though the outcome is not, as a student wonderfully said today, proper. It's not what you want. It's not correct. It is still consistent, right? It's consistently incorrect, right? Even though, right, it's not giving you the slurp that you're pressing, it's giving you the same output every time. So that input, though it is wrong, always has one output. Here's what it looks like, right? Because the slurp, if we draw our picture, always goes to only that one kind of soda, the lemon twister. This is a confusing one for sure, but that's what we're looking at, okay? So in this activity, we got started by thinking about what makes something function. How do we define a function in terms of the inputs and the outputs? So at this point, we are going to need to take a look at the back of 1.7 again on the summarizer section. And here's where we're going to wrap up. We're going to complete these very important notes, fill this in, and then we're going to be good to proceed with doing a little bit of HRW for the rest of the lesson. Hopefully we have time to do that. So a relation and a function are two types of ways of connecting or relating or mapping something in one set to something in another set. And now we've talked about sets, right? When we did probability, so we have a sense of what a set is, right? A collection of objects. Now in math, it's typically going to be numbers, but it doesn't have to be, right? We just saw sodas, right? Okay. So a relation can be any type of way to connect them, but a function is a special type of relation. And here's what's special about it. Every input to a function must have exactly one output. Can't be 0, can't be 2, must be one output. Now, technically, every input has to have a consistent / predictable output. Now, that being said, if you look at any kind of textbook, like a college textbook or something, even, believe it or not, there, you will see that generally the definition of a function is a rule or relation or mapping such that every input has exactly one output. That one that I just starred is typically what you see as the definition. All right. Now, again, we have these two sets being connected. So the inputs all live together in a set that's called the domain, and the outputs live together in a set that is called the range. So those are very important. And as we proceed to look at some more examples of these, I'd really love to introduce the idea of function analysis in this unit, depending on how things go. We're going to get to see, by looking at graphs, a little bit more precise sense of how do we talk about domain and range. So it's something worth looking at, and it's intuition that we'll build kind of as we go. All right. So throughout the year, we're going to look at all kinds of functions. Linear, we've already gotten started with in a sense. We're going to learn about maybe absolute value. We'll see parabolas that look like U's. Okay, all different kinds of functions. And that's what a lot of the study that you're going to do in high school, if you get to calculus, calculus is the study of functions. Okay, so we want to try to look at functions in 4 key ways: the A, the G, the T, and the C. Where these come from is, believe it or not, what we know from science is cells are made up of what we call DNA, deoxyribonucleic acid, and that is made up of 4 what we call nucleotides that bond together to form the helix structure of DNA. I will leave it to your biology teacher to tell you what AGTC stand for. In math, here's what we're going to do, because functions are really in our mathematical DNA. We're going to have A stand for the algebra, the way of looking at a function with a formula. The G is going to stand for geometry, because it's an integrated class, right? We look at it not only in terms of the formula, but how it looks on a graph. We have the table and we have the context, okay? And so we're gonna have to look at functions in each individual way, but also connect them together. And we're gonna see specific examples as we progress in the unit and really throughout the year and hopefully in future years. When we look at algebra, what we're gonna introduce is this f of x notation. This is called function notation. Okay, it's a different way of writing this relationship, the function, and we call it f because function typically starts with f. It doesn't have to be f. Typically, that's the go-to. Just like how y is the go-to for when you do like an equation. And f of x essentially means the exact same thing as y. They have the same meaning. They're really interchangeable. It's just that y equals doesn't really have to have that one input giving you one output, whereas a function is going to tend to indicate when you plug a number in, you're always going to get the same thing every time. You're just going to have one output. So that is what it looks like algebraically. Geometrically, you've seen some examples. So here's what it looks like geometrically, right? It looks like a graph. Okay. Now, in geometry, we have this cool thing. So notice if I run a line, a straight up and down line, it touches the graph only once. If I run this straight up and down line, it touches the graph only once. If I run this straight up and down line, it touches the graph only once. So the graph of a function will always pass what we call the vertical line test. And what the vertical line test tells us is that every straight up and down line that we run along the function will always touch the graph at exactly one place. And if it does, it's a function, because what that means, the up and down line tells you how many outputs a particular input has. So if you always have one point of intersection, you're always going to have one input for every output. Okay, that's an important thing that is worth mentioning. Okay. All right. Table. When we think about a table, right, we're going to think about our x. Now here, we're going to put our f of x. We're not going to write y anymore because we're thinking about functions. So maybe 1, I plug in 1. What comes out of my function? 2. I plug in 2. What comes out of my function? 4. I plug in 3. 6 comes out. I plug in 1 again. 2 comes out. So what we're looking for is no repeated outputs unless the inputs are the same. So what I'm saying is when you plug in a number, you're not going to have the outputs repeating, right? So what I mean, I guess I should clarify. How about this? Each x has only one f of x, right? So if I plug in 1, I only get 2. I don't get anything else, okay? Generally speaking, we are going to be making our own tables, and we aren't going to see this come up, but it is worth noting if you look at a table, what you'd be looking for is if you see the x is the same, but the y's are different, or the fx are different, that would be a troubling sign. And lastly, we have context, and context tends to take the shape maybe of a word problem. That's what we're looking at, okay? Like some kind of word problem that you need to break down and analyze. And so we'll look at some specific examples as we get into the types of functions, okay? So these are the 4 ways that we need to look at functions, and this is really the crux of today's lesson. The idea that a function is a rule for connecting sets of numbers where every input has exactly one output. The inputs are our domain, while the outputs are the range. We have our 4 ways of looking at functions: algebra, geometry, table, and context. And we need to be able to interface with each one and also go back and forth between them. In the next lesson, what we'll be doing is taking a look at a new type of linear equation. And as we do so, we're going to look at the AGTC and think about not only how do we find each one, but how are they connected. So please make sure that you are aware of what you need to do for your lesson deliverable for today. If you are doing the lesson deliverable, again, it needs to have the do now problem, the examples of write the equation of the line, and then I want you to take a picture of both sides of 1/7 so I can ensure you've done it. And please go back and take a look through anything in the video if you need help with that. Okay, I will be around again after class. Please feel free to stop by and ask questions. Thank you very much. I hope you found this video to be helpful. I'm looking forward to seeing you all in person as soon as we can, and have a wonderful day, everyone. Best of luck. You can do it.